In this lecture I will sketch weak trace equivalence as the equivalence that relates to most processes. Two transition systems are weak trace equivalent if and only if they have the same set of weak traces, and weak traces are those traces where taus are omitted. If you look at this example, we have the following weak traces, namely the empty trace is a weak trace, the trace with an AB, but not A tau B, we omit the tau, and AC are the traces of this system. So we can ask ourselves, are these two transition systems weak trace equivalent? Well, it's obvious that they are because they have the same set of weak traces. And you can immediately see that weak trace equivalence has a number of unpleasant properties. Look, for instance, at the B at the left. You can see that you can end up in a state where you can do the B but not an A, and this is not what's happening at the right side. So the branching structure of processes is not preserved by weak trace equivalence. And that is why we are always a little bit hesitant in using it. But sometimes it is useful because if you have a small transition system, applying weak trace equivalence can make it even smaller and therefore more insightful. So what are properties of weak trace equivalence? Well, one of the nice properties is that weak trace reduction allows to remove all the internal actions from the behavior. An unpleasant property is that there is no unique minimal transition system, modulo weak trace equivalence, modulo branching bisimulation or strong bisimulation. There is a unique minimal transition system. And something about which you really have to take care is that if you apply a weak trace reduction, then it can be very hard to calculate, so it can be very time consuming. And it can actually result in much bigger transition systems. So only apply weak trace reductions on relatively small transition systems. In the next lecture, we will define weak bisimulation as the alternative to branching bisimulation, and because weak bisimulation was defined before branching bisimulation, it is more popular in the literature.